Okay, welcome everybody to this Validate seminar. My name is Blakely Nixon. I'm the Communications and Events Coordinator at Validate. And just as an introduction to Validate, because we've got quite a few people in the call that aren't Validate members, we are a network of 900 researchers working in some way to discover vaccines for mycobacteria, Leishmania species, and Burkholderia cytomegalovirus, which causes melioidosis. You can join for free, and you get lots of benefits, including closed seminars. Some of these seminars that we do are closed, access to our annual meeting, access to funding that's only available to members. I'll put some information in the chat so that you can find out more about that. So what we're going to do today is I'm going to introduce our talk and our speaker. We are joined by Dr. Violet Warwick, and we're going to have some backing vocals by Dr. Emmanuel Olamijuwon, both from St. Andrews University. They're going to be discussing CAID, the CAID, an app, a no-code app, user-friendly, designed to help researchers identify candidate immune correlates of protection. And also during this talk, Violet is going to be giving us a demo of the app itself. Dr. Warwick is a Validate member, most importantly, and a research fellow with a background in drug design, clinical trials, and applying data science to medical research. And her support, and her colleague who's here to support is Dr. Olamijuwon, who is a lecturer focused on digital approaches to global health. We're looking forward to this talk, and I'm going to hand over to Violet for her presentation. Thank you, Violet.
Thank you very much. So I will just find my slides to share, and let's go full screen. There we go. Hopefully you can see my slides. So thank you for the introduction. As mentioned, my background is biological sciences. So my first degree was biochemistry. I have a PhD in drug design and experience in clinical trials. And latterly, I've done a couple of qualifications in business intelligence and data science, which is how I come to be doing this. I think it's worth saying that I'm not an immunologist. I'm also not a statistician. But in much the same way as the person who makes a scalpel for a surgeon or a retractor, I'm not the surgeon, I make the tools. But hopefully I understand the problem and the tools sufficiently to make something I hope will be really useful, hopefully to some of you. So I am going to talk about what's in the app now, and I'll give you a little demo. I'll then mention what could be added, and I'm hoping that having heard the first part of the talk, you'll be able to contribute to the second, because we're really interested in your ideas. It's work in progress, so we can still incorporate your ideas. So for those who may be new to the field, a bit of background. I don't need to tell probably any of you that vaccines are some of the best value health interventions ever invented. Literally millions of people can be saved from illness and death with a very quick and relatively cheap intervention. So say you have a new vaccine and it shows promise, and maybe it's passed safety tests, and now you want to run a full-scale trial. If the disease is rare or slow to progress, or somehow difficult to track, you might calculate that you need an absolutely enormous clinical trial. So an example of this would be the Nipah virus, which would take an astonishing 43 years or nearly 2 million people to test. So that's obviously not feasible. And so this is where a correlate of protection could make the impossible possible. So So yeah, because it could make it possible to test a vaccine with a much smaller trial. So correlate of protection is an immune marker, something that you can measure, usually in blood, that indicates whether the vaccine's actually protecting the person from the disease. And having a correlate of protection can be used to predict vaccine efficacy. It can help with decisions in clinical development, licensing, and deployment. So it's basically a correlate of risk that relates to vaccination. So a correlate of risk might be an antibody titer, something that might be related to an outcome but isn't particularly to do with vaccination. So a correlate of protection would be a special sort of correlate of risk that relates to vaccination. And you determine that by looking at immunological measurements in vaccinated and unvaccinated people. So when can you use a correlate as a surrogate? Well, in 1989, Prentice came up with some criteria for this decision. And my simplification of that is that you need to tie together protection from the vaccine, from the disease by the vaccine, and that the thing that you think is your surrogate has to be statistically related to the protection, and it has to be statistically related to the vaccine and the vaccine to protection. So the fourth criteria for that Prentice came up with was that ideally the surrogate should explain all of the clinical endpoints, but in practice that's quite hard. So I think that fourth criteria has been a little bit relaxed. But in short, it's a statistical exercise in correlating protection and the vaccine and the surrogate. So in practice, what does this mean? So this is one of those slides that is really complicated, and the only purpose of the slide is to show that complexity. So no need to start looking for patterns or anything. The only thing to notice about this slide is that it's a table full of numbers. And so this is the sort of thing we might start with. So it's usually a data set of blood results for people who were given a vaccine in a study. Often the first column will be a measure of whether we think the person is protected or not by the vaccine, or it might be the extent to which they're protected. And ultimately, we're looking for other columns, other variables in the data set that correlate with that first column. There are some problems with this. I'm sure some of you know all about this. Problem one is actually knowing whether someone has been protected or not. That can be a really big problem, but it's one that maybe we can talk about later. Another problem is that we're likely to have more measurements than we have people in the data set, and that can make things difficult. So the app needs to have ways of narrowing down the number of features, that is, narrowing down the number of columns that we have. So with that background out of the way, here's the problem that we've been set. We're funded by the Wellcome Trust to develop a platform to discover potential correlates of protection. It should offer both classical statistical methods and machine learning tools. It should work within and across study datasets. It should visualize findings, and it should be user-friendly. So our solution is a combination of things others have done. It can run on low specification computers, and we're really keen that this is an app that will be useful in perhaps low resource environments. Maybe low and middle income countries might find it particularly useful. But we hope it'll be useful everywhere, really. We want it to be user-friendly. You might comment on that. And it's not finished. So there's time to have your input if you would like to. We're really interested in your feedback. So here's an outline of the functionality in the app. So the data preparation addresses the need to analyse both within and across datasets and helps to deal with missing data. The data visualisation helps the user to get an intuitive feel for what's in the data. Already touched on the problem of having more measurements than subjects, and feature selection methods help to narrow down which are the important features, that is, which are the important variables, which columns are most relevant. And then classical regression can quantify the relationships. So I want to look first at the data merging functionality. So here, we have two data sets that we might want to merge together. So we're going to append one to the other. And you can see that they actually have two columns that look like they have the same sort of data in them. But there's one column, the green column, which has column name in common. So that those green columns will be automatically appended one to the other. But as users, we happen to know that the information in the blue column and the cyan column are actually basically the same. They just don't have the same names. So we can tell the app that cyan equals blue, and then when we do the merging, it will append those as well. So inevitably, having appended these two tables, we have some missing data. And that's a problem. We need to be working with complete data sets usually. So we have a subsetting function that will help us with that. And it's based on the mulset package. Don't know if anyone's familiar with that. But it's been adapted to work with all data types. And it lists the possible subsets, like complete subsets that are available, and then the user can choose between them. So here we have three possible subsets denoted by the three colours. And then you can continue with your chosen subset. So once you've got a complete data set, no missing data, then you can create a correlation matrix. So this shows you the extent to which each variable is correlated with each other. So as you can see, we've got a dark band diagonally across this diagram because that's where each variable meets itself. And then the correlation is 1, so you can see from the color code there how it works. So in this particular diagram, we don't have any pink or red spots, so we don't have any negative correlations, but we could potentially see that as well. It's really good to see which variables are correlated with each other, because where you have correlated variables, it can make it difficult to tell whether the coefficient is statistically significant or not. So where your predictors are highly correlated, you might want to remove one. Alternatively, correlated predictors can be combined, for example, by principal component analysis. So this is the plots page, and it's just to get a feel for what's in the different variables. In contrast with the visualization page, where we would look one variable at a time and we look at it against the outcome. And we can also choose another variable that's got categories in it so we can compare the categories. Time to event data can be visualised with the Kaplan-Meier survival curve. So here you would have a data set where you have a column to say whether that individual has survived or not. And you could code it 0 and 1, where 1 is dead, or you could code it true false, where true is dead, or you could code it 1 or 2, where 2 is dead. And again, you can choose a field that has categories in it and it will compare those categories for you. So moving on to the feature selection. The feature selection page uses the Baruta algorithm. Now, why have we chosen that? There's a few ways of doing it, but we've chosen Baruta because unlike most algorithms that do this, it's conservative. So it will keep all relevant features. So some algorithms that do this will go through the columns in order, and whether the column is discarded or not depends on the order in which it appears in the data set, and that seems risky to me. So Baruta doesn't do that. It will keep anything it thinks is relevant, regardless of the order in which it occurs. So Baruta is quite easy to use and it's quite easy to interpret. So it measures the importance of each variable with respect to the specified outcome variable. And it does that by creating shadow versions of each variable. So it makes a copy of that column and it jumbles up the data within that column. So it's got the real data set and then it's got a shadow data set. It trains a classifier and then it checks whether the real feature has got a higher importance than its shadow feature. It removes the least important and then repeats the process iteratively. And it outputs this list of features with importance scores and a color-coded plot which shows the same information. So here it's put the green features. They are the ones that are confirmed as being relevant. The red ones, it has rejected those as being not useful. And the yellow ones in this picture, it's not sure about, and it hasn't had enough iterations to be sure about these ones. So you could, if you wanted, increase the number of iterations and run it again. So moving on. The next page allows you to build a decision tree, and it uses the rpart function for anybody that's familiar with that. And you just have to give it a data set, tell it what the outcome is, and set the complexity. So a lower complexity number gives a more complex tree. So you can play about with the complexity and see the different trees that you get. This tree has been created from the Titanic data set. So some of you might be familiar. It's a data set of survivors of the Titanic. And it shows the variable importance in a bar chart. And we can see that sex is the most important variable. And so we know that intuitively that women were put in the lifeboats first. So I'll be showing you those pages in a demo as well. So this page is principal component analysis. So That's a technique that looks for linear combinations of the original predictors that explain a large proportion of the variation in the data set. And it only works on numeric fields, and it requires all rows in these fields to be populated. It also requires the fields to contain some variance, so fields without variance will be omitted from the analysis. The linear regression can work on cross-sectional or panel data, and there's the opportunity to transform your outcome measure either by square root or log or square, and it produces several visualizations of the result. The mixed model allows you to choose variables for fixed and random effects as well, and to look for interactions between fixed fields. As well as the usual numeric outputs, it also plots residuals. So, next I'm going to give you a little demo. So once you create an account, you can set analyses running and then come back to them later. So you can even close the app and the results will be stored for you. Hence, you don't need a powerful computer to run your analyses. So I'm just going to stop sharing and then share the actual app. So share. So here is the app. So this is where we read it in the data. So I can browse for my files. I'm going to pick some that I think might be useful. So it lets you upload 5 CSV files at once. And here the 5 are listed. Now, I haven't chosen all immunology files today. I mean, it should work with all sorts of data, and I wanted a sort of well-characterized data sets, and for example, things that you can kind of intuitively, you know what to expect from the data. So here we have a little preview of what's in our first table, which columns are there. We can look at the structure, so the data types for the different variables. We can see how complete they are. So this makes, this is a complete data set, so it makes a very boring picture. But if it had missing data, it would appear as black in this diagram. And then there's a summary here of what's in the different fields, and we can do that for each data set. So let's start by merging a couple of data sets. So I'm going to pick a couple of data sets that I happen to know have very similar data in them. So as soon as I pick a couple of data sets, then the app will show me which column names are in common between the two of them. But as I was saying in my presentation, we might want to connect to append together other columns as well. So we can specify other columns as well. So in the drop-down, it's coloured blue, column names which are the same in both data sets. So we don't need to worry about them. They'll just happen automatically. We're interested in the green ones, so I'll pick a couple of green ones. And I'll say, add that to your list to match. Let's have some more. And we could pick more, but I'll just append these two data sets, and now it will include these in the composite table. So we can see our composite table has appeared, and we also have a diagram that shows us the missingness plot. There's a lot of missing data, so that's a bit of a problem, but we can do something about that. So if we go, oh well, first of all, we'll go back to our read data page. So now we can see our composite data set here in the list. But let's find some subsets. So we'll choose our new composite data set. We could choose to miss out fields if we wanted, but we'll just look for complete sets. And in this example, there are 3 possible ways of finding complete data in there. And so anyone who's familiar with the mulset package will be familiar with this. We can choose which one. So we'll just choose the one that gives us the most data points on this occasion. We can preview our subset. Now at this point, we could decide, actually, don't think I want that. We could click undo, but let's decide we're going to keep this. Yeah, you could click undo, choose another one, and preview the next one, but we'll just save that, and then that takes us back. And now our subset is there, and it's showing us that it is indeed complete. Now that we have complete data, we automatically have generated some correlation matrices. So it creates matrices for every complete data set. These are all the ones I loaded. This one is the composite, so it's not complete. So it's just said, can't do it, missing values. But our new subset has a matrix. So moving on to the plots page, let's have our new subset. Yeah, we can change the size so we can actually see what's there. We could decide we want some more columns. There we go, that's a bit of a cliffhanger. So now we can get a bit of a good look. So it's plotted each variable against the group, which is mild or severe. The visualize page, let's just plot anything. And then we can color our categories. Put them onto separate charts if we wanted. So that lets you have a bit more detailed look. And Kaplan-Meier curve. Oh, that's the lung data set is good for that. So the status says whether people are alive or dead. Time has a time to events. And then let's compare ECOG and create plot. And then we can see people of different performance status, different survivals. And we've got a little table of the data at the bottom. So moving on to the analyses, start with feature selection. So this is our Baruta. Apparently, Baruta is a forest-dwelling mythical monster creature. So that's because it's based on decision trees on the random forest classifier. So we have our data set, select an outcome. As I mentioned, you can choose how many runs you want to give it, and then we would click run. I'm not going to click run right now because it would just it doesn't take long, but I think for now we'll just go to one I created earlier. Summary of results. The table where it has all variables, whether they're confirmed, tentative, or rejected, and the graph, which is a bit more informative. So the linear regression, as I mentioned, you can choose cross-sectional or panel data. So for panel data, you need to tell it how individuals are identified and the time period. I don't have the right data set for this. So you tell it what the outcome is, and then you can transform if you want by square root or log or square, add covariates. So you can just add some, and then it tells you which ones you've added, and then you think, oh, that was a bit of a mistake, then you can remove some and run the regression. But again, I'm just going to let's look at number 3. That's a nice one. Yeah, so this is one of the good things is that you can pull up results that you made earlier. So you can run several different analyses and then compare them. Could compare like that. Mixed model. So that gives you the opportunity to vary just the intercepts or intercepts and slopes. You can use logistic or linear regression. Choose your fields. For fixed, we won't remove any because we want both of those. We'll look for interactions between them. And then that's our random effects. And then we get a little summary of what it is that we're going to run. And then if we click run model, we would get this result. So here it tells you that we put in attitude and gender, that we have looked for an interaction, and that the random effects are scenario and subject. Tells you the coefficients and the ANOVA and a plot of residuals. Then decision tree page, Titanic dataset would give us this. So it tells us we've used the Titanic dataset, the outcome is survived, and we've used a complexity of 0.2. I always think the importance plot is quite informative, and it details the model for us, should we need that. And then this is the principal component analysis. And that's good for showing you if you have variables which are very similar, that might be correlated. And this is the loadings table, which shows the contribution of variables to your principal components. So that's that, moving on, this is it's not finished, but I'll just give you a sneak preview. So the plan here is to have an AI assistant, but it's not ready for demo yet, so just watch this space. And then the last tab is just sort of housekeeping things. So that's your demo. So if I go back to my slides, and pop that open. So ideas. Well, you've seen that we've got an idea for an AI assistant. I'm wondering whether some sort of unsupervised clustering would be useful. I have been working a bit with positive unlabeled learning, but I haven't got it working sufficiently yet to include it. But really, we're interested in what you think. This is the over to you bit. Have you any ideas, suggestions? It would be great to hear.
Yeah, so hi everybody. If you have any questions, ideas, suggestions, it'll just also be interesting to hear thoughts about how you would use this in your research as well. I think that'd be quite an interesting thing if you just have a thought on that. So you can raise your hand or just come on camera or type your questions. So do we have any thoughts or questions from anyone? I do have a sort of broad question, Violet, which is the devices you can use this on. What kind of is this going to be something you can use on your phone, on a tablet, out in the field? And does it always have to have an internet connection? I'm just thinking of people working in LMICs, they might not have internet connections and things like that. So is this something that you're going to be able to have on multiple devices, different types of devices?
Yes, that is the plan. And yes, it is ideal for situations where you might not be connected to the internet all the time. So you could get onto it and you could set something running, and then if you close it down or lose connection, it will still be running there, for you to pick up the result when you next get connection.
Agnes, would you like to come on camera and say hello and ask a question? Agnes, oh, there you go.
Hi,
Hi,
this
Agnes.
is Agnes from Zimbabwe. Thank you very much for the presentation. I wanted to find out in terms of the decision tree, how do you use it? I saw you presented something, but how are you going to make a decision using that decision tree in terms of the correlates?
Let me just go back to look at the slide about the tree. Find a tree. So I think the variable importance is really useful because that's one of the things that we're looking for, to know which of our variables are the most important. And a tree is particularly useful because if you have interactions in there, that will show up in the tree. So if you have something that appears multiple times in the tree, then you've got a suspicion of an interaction. So it's quite useful in that way.
Oh. Does that answer your question, Agnes?
Yeah, there was also a table that she opened up while she was explaining the decision tree. There was a table
Oh,
with
yes, that's
figures.
right. It's basically, it shows the information that is in this tree, but it just shows it in words rather than in pictures, but it's the same information. It's a sort of formal description of the tree.
Okay, so we are saying the more the repetitions, the better the protection. Is that what we are saying?
I wouldn't quite put it like that. There's probably someone in the audience knows the answer to this much better than I do, but I would be looking at the variable importance in this table, and the tree itself shows you how the variables are kind of related. And if one of the variables appears more than once in the tree, that suggests that you might have an interaction. So earlier on, I mentioned that it might not just be one variable that is like the magic variable that's going to be your correlate. It could be a combination, and you could get a hint of that in the tree.
Okay. Thank you so much. I think I got it now. Thank you.
Hi, Taru, do you have a question? You want to come on camera?
Yeah, I do have a question. Thank you, Warwick. That's a great presentation and a great app. I have a question mostly related to the things that you have used in there. You have used a Titanic data set, and the other data set was like the lung data set in which you have showed the most of the antibody responses thing in there.
So there's actually only one immunology data set that I've used, and it's a COVID data set.
Okay.
Yeah,
you-
so the lung one is actually cancer.
Okay,
But
interesting.
yeah, I mean, ultimately it's a correlation engine. So yeah, I've chosen to demo it with not.
Have you tried using this app or pipeline with more complex data sets in which you have more immune cell populations at different stages of from the same, like the longitudinal analysis from a same patient with and without vaccine? I'm asking this because a few of the relationships looks linear, but when you actually look at those data sets, there are a lot of non-linear relationships in there.
Well, if you have a data set that you were able to share in an obviously de-identified way, I'd love to give it a whirl.
Okay.
We're hoping that the app will be available for people to try, but not for a few months yet. So if you had some data that you would like to try it and you were able to share that data with me, then we could have a go.
Okay. I have one quick thing as well, if that's okay. Is it possible to add a Markov model in this your app as well? Because I was thinking
Markov.
I
Yeah.
think that would be also good because sometimes the things also depends on just the previous event, but not, go with the detailed relationships and flow. I think adding that would also would be good in this one.
Great. Brilliant. That's the sort of top tip we're looking for. Thank you.
Yeah. Nice work, Violet. Thank you.
You've sort of covered this, but Eliza in the chat asks, I would love to try it. How can we access it?
Yes, so in a few months' time, in autumn, we're hoping that it will be available on the web and that people will be able to do some beta testing.
Make sure you email Validate or email me, and I'll make sure that goes out to Validate members because people work with a broad range of data sets here, and they can test it for you, and they can test it out. So I'll put that in one of our newsletters or something. Diego, would you like to come on camera to ask a question? I'll give you a few seconds. Or make your statement, I guess. Diego Aznar. No, okay. Diego said, I would suggest to add explanations and/or descriptions of what the numbers mean for the context for people who are not too statistic savvy.
Yes.
So just a suggestion there.
Yes, that's great. Yes, we should do that.
Thank you. And Tuhina, would you like to come on, say hello and ask a question?
Thank you. A wonderful presentation and looks like a very promising app. Quick question. I know you're looking for data sets right now, and I'm assuming those will be like human data sets. But are you planning to use animal data set as like a positive machine learning thing?
Yes.
Because we know at least those studies come first, and then only we look for human correlates of protection.
Absolutely.
It will be
Yeah.
a much better behind the scene machine learning with those data sets.
Absolutely. Yes. Animal data sets would be most welcome.
Okay, wonderful. So yeah, whenever you have the app ready, I'll be more than happy to do one of the beta testings.
Brilliant. Thank you.
Thank you. Thank you. All the best.
Cheers.
I hope you don't mind, but I'm just putting in the chat some information on how you can join Validate for those in the chat who aren't Validate members. Do we have any other questions, comments, suggestions for Violet?
I got one more quick question.
Go ahead, Taru. Go ahead.
Okay. Sorry about it. I should have asked this before. When you were showing the data sets, I got one more question about the data normalizations about the different human sets. Because when we measure antibodies, or even we measure like cellular populations, and human PBMCs are like and serums are like very variable in terms of antibodies and proteins. So how do you normalize the data and correct for the batch effects in that particular like if you're merging all the data sets together to find out the protection?
That's something I think we need to add.
I think that would be really, because I've seen a lot of variations in those data.
Yeah, so yes, when we've run specific algorithms, I've put a line of code in to normalize, but maybe we should make that possible to do that explicitly up front. So yeah, we could put that in.
Yeah. Okay. Thank you.
Okay. So I'm just going to give people a few seconds to decide if they want to ask a question. Again, you can type it in the chat. Someone speaking then.
Can I ask one, please? I don't know if
Go
I
ahead,
missed.
Bruno.
Thank you, Dr. Violet, for your presentation. It seems to be a very useful app. I don't know if I missed this, but is it up for tests already? Can we get it somewhere? Can we use it online?
Oh, soon. In autumn, we hope to get it online so that you can have a go and do some beta testing. So
Great, thank you.
just a few months.
And I added, Bruno, that I'll make sure Validate members know about that, so that they can get involved. So I'll spread the news amongst Validate members. One of the many benefits of membership. Anyone else? Comments, questions? Because it'd be nice to let Violet go just before the hour's up. Okay. No, that was a really nice round of questions and a fantastic presentation. Thank you very much, Dr. Warwick. That was very good presentation. And thank you everyone else for your sort of excellent questions and engagements. So if you could just show somehow your appreciation for the presenter, Violet, just by saying thanks in the chat. And I'm gonna stop the recording and say thank you one more time to everybody who's attended and our amazing speaker, Dr. Violet Warwick. Thank you.
Brilliant. Thank you so much.